Hey everyone, with you Elena Litvinova, and in this video we continue to learn algorithmic section and going through binary trees, and I will explain you how to resolve one medium task on Leetcode. Before, of course, not forget to subscribe on this channel, press bell icon and go! I already had one video for binary trees on my channel where we created a class of binary tree in JavaScript, and there we had some traversals such as depth first search, breadth first search. Basically, binary tree is very popular on interview processes, especially in large companies, and of course we should to know them, to learn them and to go through them. And today I decided to choose one interesting task for binary trees, which is binary tree right side view. If we go through the description, we can read: given the root of a binary tree, imagine yourself standing on the right side of it, return the values of the nodes you can see, ordered from top to bottom. So we have a binary tree which we can see like an array for print here, and it is a structure like that. Turn, we just should imagine that we stay here, and everything what we see we should return from top to bottom. So here it will be 1 3 4. If we go further in the next tree, we will return 1 3 4 5. In this tree 1 null 3 1 3, and if we don't have anything, so just empty array. How many node values we can have, and we should create a decision for this task. Before this video, if you want to try to resolve or imagine how you will resolve this task, I absolutely recommend this, because when you try to resolve by your own, even if it will be a very difficult time complexity or your resolution will be not easy for understanding, it's very cool for your brain, because you start to work and you try to create any decision, and after it you can look at how will be able to create an easier decision with better time complexity, space complexity. And of course I recommend my first video about binary trees with different traversals. There we also will use one of traversal. Which suggestion I had when I tried to resolve this task? First of all, I decided, okay, I need return an array where I have elements which I see from the right side. There are different traversals: depth first search and breadth first search. Depth first search, there are 3 levels there: pre-order, in-order, post-order approaches, and when we go into the depths of the tree. Breadth first search, when we go through the lines of each tree, so first line, second line, third line. And I decided that it will be much better to use breadth first search and just to understand which last element on each level. Because when you use breadth first search, we go through each line 1 2 3 5 4 and just add in the array the last element, right? And let's try to resolve this task with this approach and go. If we don't have root, we just return an array, right? Root, if you look at how each node looks like, so it have value left and right, so it's just object. And after it, what should we do? We should create a stack, and here I decided to make it a little bit different. So we have node which is root and level, and start with 0, and const result object, a result array which we return in the end. So here we will return result. And what we will have? Breadth first search. If we stack length return for us this approach, first of all need to pick up this element. So we say stack shift, we pick up first element, and we should push element at the bottom. So we should say if L not left, we start from left, we should say stack push, and here we should to put another object like that. But the node will be this one, and level will be level plus 1. The same we do with right. right. And the same. It gives us opportunity to go from the left to the right, and because of it we go 1, 2, 3, 5, 4, and not depend how large our tree it is, we always will go in this direction. So we have level how we should fix our result. The decision which I decided to, I have imagined that it will really cool to work. I just use result. Here I put L level, and I say that this is L not val, so I need to save value, so not the whole value. And it means if we go through left to the right, last level we will work here will be last element in the level. And if we go on first level, we just say result 0 is equal this element value. If we go here, we say result 1 is equal to, after it we push right here as well, we go to the 3 and we say at the end that result 1 is equal to 3. We rewrite the result, and I decided that this decision is really cool and it works. And if you look at it, it's quite easy. You don't need to use a recursion. If you use just loop, it means that you never will reach the maximum of recursion call stack, and this basically very cool to use to binary trees. And what is about time complexity, we here just only once go through each node. It means that time complexity is big O of n, so linear. And if we run this code, we will see that everything works, everything is green, and yeah. And if we submit, what we see here, so runtime is very amazing. It's 100% of any other decision which was suggested at Leetcode. With you were Elena Litvinova. I hope this problem and algorithmic task was interesting for you. Of course, not forget to subscribe on this channel. Not forget to subscribe on my social network, and see you in next videos. Bye bye.